Ah! I hit record and then I waited like half a second and now I want to start over, but I'm not gonna because this is gonna be just a one take video with a lot of mistakes, so there's already the awkward start. Okay, so you know what this video is about. You looked for it, you found the title. I'm glad you're here. I wrote this software and I want everybody to use self-balancing stuff. So before we start, a couple of disclosures. One, I've tested a few different hardwares and I found that some hardwares, not going to name any names, don't seem to work as well for self-balancing applications. They're fine for a skateboard. I'm going to use them for a skateboard, but for the exact slight adjustments, I don't know what it is with their hardware, but it just doesn't work as well. So yeah, just this here, this box works fine, and obviously the Trampa VESC 6 Plus works amazing. So just know that spend a couple extra bucks on your hardware, you'll be happy in the long run. If you've already got cheaper hardware, try it, see what happens. So the other thing is that this code has been merged to master. This is what it looks like now, but things will definitely be changing, and I don't know how applicable all this information will be in the future. And this isn't even released yet at the time of recording. So, but based on the fact that it is already merged, I think that this will be pretty similar to the actual feature set. So let's start off first. I want to go through the gyroscope settings and show you how to configure a gyroscope. So I've got this here box, and this is what I'm going to use. And let me pull up the app. I mean, you already see the app because I've got OBS running, and it's pretty cool. But I was looking at myself in OBS instead of the app. Okay, so here is actually an MPU 6050. The cool thing that's not necessarily documented is that the MPU 6050 works if you use the MPU 9250 setting. So just going to plug this guy in to the I2C ports. You can see SDA, SCL on both sides, and power and ground. So now I'm going to connect to this box, and I'm going to load the default app and motor config, write all that, and now if we go to IMU, you can see that there is no data. So I'm shaking this IMU around, nothing is happening. So the first thing we need to do is go to this drop down to external MPU 92X50, and now you can see, is it working? Oh, no, it's not working because by default the app is UART, and UART will override those ports and you can't use them. So we'll change it to no app, or we could even actually, let's change it to balance because I'll want it there later. Balance is the balancing app, and now you can see there's data in the balancing app, hopefully. And in IMU, what do we have? Did we write this? I did. Did I plug this in correctly? I did. It's lit up. Are we connected? It says we're connected. Oh, sometimes this gets a little bit weird, so let's just reboot it. It's not even rebooting. So I'm going to disconnect and power cycle. Or let me just disconnect and reconnect. Yeah, something is weird. So let's power cycle this. I found when messing with the UART settings, I think it sometimes messes with the USB. I'm on Linux, so I don't know why, but my machine takes forever to connect to the VESC, but on Windows it's usually pretty quick. Looks like this video is off to a real great start, but we're going to go with it. If it's 20 minutes long, it's 20 minutes long. There we go. We're connected. Now we've got data, so we have to change the app off of UART, and we have to change the external type. Once you're off of UART, I've been able to hot plug different gyros and everything kind of real time without even changing any settings, so that's pretty cool. Okay, so now that we've got this data, let's talk a little bit about configuring it. So my hands are off the gyro, and something that you will notice is gyro drift. So if we look at gyro, we're going to have to wait a little bit till this large variance comes off the graph, and then it can zoom in on the smaller numbers. going to be a real efficient use of time in this video. There we go. You can see that my gyro X is off by like a little bit, like 3.5 G away from 0 at a standstill. I'm not moving it at all. So we're going to want to fix these offsets. Now there's two ways you can do it. There's these compensations you can add. So if I add like an X compensation of like 0.5 degrees per second, and then write the app config, you can see it'll move towards 0 at half a degree per second. And so in just a few seconds, it'll get all the way to 0. You can see that number on the graph over here, slowly working its way up, because at standstill, your rotation in all axes should be 0. Now the accelerometer is different and harder to configure because you've got gravity on one axis, and then when you're not completely flat, all kinds of weird things happen. And the accelerometer seems to be more accurate, so I wouldn't worry about that one for now. We'll just try to get the gyro good. So there's kind of two strategies you can do. You can see there's a max offset comp, which will limit you to 5, and this being at like almost 5 off to begin with is kind of bad. But supposedly these will drift over time as well. So you can try to manually tune it. Let's do that just a little bit here. So let's change this to 3 point, no, this is not that one. So here's the manual tuning in the regular offset, 3.5, do that, and now, okay, that went in the wrong direction. So let's make it negative. That's a 4, not a 5. There we go. Now you can see it's closer to 0. So we'll get a little bit more availability in our offset compensation. So that's the idea. Basically, you want all of your axes to be averaging around 0, and then you also want to add some compensation. Now, when you're doing the balance app, the motor is going to be balancing in one of the directions. So whichever axis your motor is balancing on in the current software, this will probably change in the future, but for now, you don't want to use compensation on that axis. I've found that it just messes it up and it gets kind of loopy because it's constantly twitching, and it just makes it unhappy. So we can tweak this a little bit. We can do 1 on our red, which is Y. Let's add 1 there. Write that app config, and it should be even closer by default now. And so we also need to figure out which one is going to be our balancing axis. So there's kind of two ways you can figure this right now. In the balance app, you can change what is your main axis and your cross axis. I suspect that's going to go away because you can actually reorient your gyro in the IMU page, and most likely we'll just change it so that it is always pitch that you're balancing on. So right now I'm holding the gyro flat. Let me see if you guys can see this. Can you see it? Yeah, okay, you can just barely see it in the corner of the camera. If I go this way, that is roll. So if we wanted to have the motor be this way, we would have to change that. And I believe if we do a yaw of 90 degrees, then we write app config. Now this should be pitched. There we go. So now this way is pitched. You can mess with those settings and tweak it to get it whichever way you want, and I recommend getting it so the pitch is with the motor and roll is going to be opposite your motor. So for example, here's my view. Actually, wait, I'm prepared for this situation. Camera number 2, here we go. So this is my electric unicycle. This way it's going to be my pitch. This is the way that we're balancing. The roll is going to be this way where it tips over. Now currently you would want to make this your main axis and this your cross axis. And then your third axis is yaw, which we don't care about because you can ride in circles all day and it should have no effect on the software. So that is kind of the basics of setting up a gyro, and we're 9 minutes in. Wow, this is going to be a really long video. Pretty rambling. I'm sorry, everybody. So there are also offsets for accelerometer. So here, for example, I'm going to put it flat on the table, and this table has not been leveled with a bubble level, and the bottom has some solder on it, so it's not totally flat. But you can kind of see that the red and blue are 0, and the red and green, no, yeah, the red and blue are 0 and the green is 1. So that's kind of like which way gravity is making this thing always fall at 1. And if you knew everything was perfectly level, you can try to tune it so that everything is exactly either 0 or 1, depending on what it should be. But this one is much closer than my gyro, as you can see, so we're typically not as worried about accelerometer calibration. And yeah, you saw what the compensation did, you saw all that. Okay, so the other thing here is the AHRS mode. Now the AHRS is the algorithm that determines your roll, pitch, and yaw from gyro and accelerometer data. And there's two options, and actually I believe only the first one is implemented and the second one does nothing currently. So the first parameter here, confidence decay and beta, apply to Madwick. The Mahoney's don't do anything unless you're on Mahoney, which I don't think is implemented. So for the accelerometer confidence decay, I found that that value doesn't seem to have much effect. For the beta, you typically want a low value. So 0.1 is already a pretty low value. Now, if your gyro is not properly calibrated and you put in, let's say, a really low value like this, your roll, pitch, and yaw will just start to drift randomly. So you want to make sure that your gyro is calibrated well, and then you can use a low beta. So a low beta of like 0.1 or 0.01 or 0.02 will make the app balance really smoothly and have much less twitching at a standstill. So that's pretty good. Something I found though is if you're specifically doing like a skateboard style wheel, if you put it at like 0.1, it has a really cool sort of like slow, flowy kind of feel that you might like, but the board will be a little bit more twitchy, so you can experiment with that on your own. Another thing to change is you want your sample rate to be 1 kilohertz for balancing. It just works way better than 200 hertz. It's just a little bit too slow. So that is basically everything for balancing. Now, while I've got this here, I'm going to plug in this breadboard, and this breadboard has an MPU 9150 on it and also these 3 pins. Now, these 3 pins I'm going to use to show you how the switches work in the balance app. Now, we're kind of skipping a little bit because I'm going to set up that unicycle, and the unicycle doesn't use switches. So for now, we're just going to use this. So I just plug that in, and as you can see, when I move the board, it's already moving the gyro, which is kind of cool. You can hot swap an MPU 6050 for a 9150, and it seems to be okay. So my use switches is set to false. I'm going to set use switches to true, and I'll show you what these things do. So now I've got these 3 wire ends, and basically if I touch the one, so also all of these settings, if you click on the help icon, it'll tell you useful stuff. So if I touch this blue wire to this pink wire on bottom of the screen where my mouse is, you can see switch value goes from 0 to 1. And if I touch it to the other 2 wires, you probably can't see this, but anyway, it'll go from 0 to 2. And so what switches for are for if you have a wheel and you want foot pads on it, something like this. So this is a Cush foot pad. Some of you may have seen this, and there's 2 D.I.Y sensors on here. I'm gonna plug this thing into here, see if I get it correctly. Okay, that is wired in, and now it should work. Oh god, it fell off my desk, and it unplugged. I'm sure you're all very important people, and you're unhappy that I'm wasting your time right now. I hope your time is worth a lot of money, and you're very angry about this. Okay, there we go. That is connected, and now you can see if I push this one, switch value goes to 1. Push this one, switch value goes to 2, also to 1, sorry. If I push both, it goes to 2. And you can see the state next to it actually goes to running because we're now in a valid state. If I take one off, it'll go to fault. Take the other one off, it'll go to fault. It actually won't go to fault if there is a bunch of current. So let's see if I can get this. I need to start it when it's centered. There we go, now it's running. And now I've made my D.I.Y value go up. I don't know if current will actually do anything. Yeah, current won't do anything because there's no motor connected. So sorry, that was just more time wasted. But anyway, you can see there are switches in action. The way dual switches work, you've probably seen some product out there that have two switches. You can look up how they're used. If you only want to use one switch, you can still use this option and wire from the power line to your switch, and then from the output of your switch, just wire to the two outputs of what would have been two switches. It'll just come from your one switch, and you'll be okay with one switch. Okay, so that is basically all I wanted to show you on my desk, and you saw that you can use switches and an IMU at the same time, which is pretty cool. And you saw you can use an external IMU, and this was all done on a FOC box, which is a V4 hardware. There it is. So now let's connect to my, oh well, I left you on this screen. Whatever, I meant to go back to the other screen, but I think you'll be able to see everything that you needed to see anyway. Cool, so now we're on this screen. You were staring at my feet the whole time. Let's set up this wheel. Now, I think this wheel is currently configured to just work. Oh god. So I can just show it to you working, unless I broke something. I might have broken something. But then I'll reset it, and I will completely configure this wheel from scratch. Okay, now, this one is working. You can see it's balancing. I can step on it. I'm risking my life here for you guys, but it totally works. Anyway, it works. Not the most perfect software ever created, but as far as I'm aware, it's better than any other open source options out there, so that's a win. Now there's a bunch of safety features. For example, if I lift this thing all the way up, it gets to max speed and it cuts off, so it doesn't run away. Anyway, now that that's there, so now this thing's got a built-in IMU, because this one is using the Trampa VESC 6. So let me tidy up my desk a little bit. Get this out of my way, that out of my way. This one's going to refuse to get out of my way. Okay. So now let's switch back to this view and set up the motor. So let's connect. Just going to nuke all my settings. Load the defaults for motor, load the defaults for app, write the app, write the motor. Oh god, what have I done to my working wheel? Alright, so now let's get this going. So we're going to use, first thing is going to configure our motor. So let's see what the defaults are here. Let's change this to, my battery is 12S2P Samsung 25R. So I'm going to limit myself to 40 amps because it's 20 amps continuous on both, just to be safe. And now also going to turn the max current min and minus to 5 amps right now, just for safety, so that it doesn't spin up like super hard while we're working on things. Let's write that. Now for the voltage cutoff, I'm not actually going to use those because we have a low voltage tilt back in the app, and that will make the wheel start to tilt back when the voltage gets kind of low. So just make sure to set that at a safe value. So here's the current. Now here's general FOC Hall sensors, which we're using. You definitely want to use Hall sensors in FOC mode. So now let's configure FOC mode. Let's detect the Hall sensors first. So you can see here, kind of putting my foot on the wheel so it doesn't freak out, and I'm letting it sit on its side so it's nice and safe. Okay, so Hall sensors have been detected. I'm going to apply that, then go to here. This is Hall censored. Do this RL linking thing. I don't know what any of this is, but this is how you set up a motor. Okay, do the gamma. Again, I don't know what gamma is, but it sounds cool. Okay, well that's not working. I think it's because I set my max current to 5. Oh, it did work. Sweet. Interesting. Let's write this motor config. I'm going to turn on the keyboard controls and see if I can. Okay. I can spin the motor. It seems to be working. Let's show you guys that I can spin the motor. Where are we here? You can see. Oh, using the keyboard in the wrong app. Go here. Alright, you guys can see the motor is spinning. Awesome. Okay, so now that that is done, and we've got a nice safe current level maximum. Again, not a lot of power, not going to kill us. Its absolute max current is absurdly high, but that's fine. Cool. So now let's go to the IMU and do what we did before. So we've got internal IMU. That's good. Now we want to orient it such that we are balancing on the right axis. So let's, right now when I lift the wheel up into riding position, you can see that it's not quite right. So I believe what we want to do is have pitch. Which one is pitch? Yep, okay, so we pitched it 90 degrees. Let's write that app config. Did that get it to 0? That did get pitched to 0, and now we're rolling instead of pitching when I rotate my wheel along the motor axis. You're just gonna have to trust me I'm doing that. So if I yaw it by if I yaw it by 90, right app config, there we go. So now I'm moving the wheel and it is going correctly. Let's see if we can show you guys. Yeah, okay, you can see this. So now if I do this, pitch moves. If I do this, roll moves. This is what we want. If we twist it, yaw moves. That is perfect. Okay. So now what else do we want to do? Our mad width beta is kind of high, but we need to make sure our gyro is stable first before we turn that down. So let's look at this and see where our values are once this big movement gets off the graph. It's all kind of close. I'm just going to not tune it at all and use the automatic compensation. So let's get, which one is pitch? Pitch is the red one. The red one is Y, so we're going to do 0.05 and there 0.05, so we're going to leave Y alone, and we're going to have the other two automatically centered. Now let's see if we can actually manually tune Y, try to get a little bit of a better result. So Y actually looks like it's basically perfect. I mean, it's so close to 0, I'm not going to worry about it. So let's write this app config, and now blue and green should work their way down. You can see green is slowly angling towards center. Am I still on foot view? I'm still on foot view. Okay, yep, the green is slowly working its way to center. So with 0.05, it would take a few seconds to get to 0. I don't know, a quarter, no, what is it? I don't know, I can't math. A 20th of a degree per, I don't know, yeah. Yes, 1/20th of a degree per second, so 20 seconds, and we've been around 20 seconds, and now the z-axis is pretty centered. So these are going to be our values, and our gyro configuration is now, oh wait, no, we want to change this to 1 kilohertz. Let's do that, and now let's drop this beta. What the heck, I think I just dropped it? What did I do? Oh, so I've got these buttons here enabled, and that when I push buttons it turns up the motor, which is why, another reason we set our current really low. That was only 5 amps trying to kill me instead of 60 amps trying to kill me. Okay, 0, are we connected? Did we break our USB port? Oh, I hope I didn't break my USB port. Oh, thank God. Okay. Thing still works. Alright, let's make this 0. Let's do 0.3, just to be safe. A little bit high. It'll be slightly twitchy, but it's not too bad. Okay, now everything's good. So now let's change our app to use to be balanced. Write that. Now we're here, and now we've got real data in balance. Sweet. So we can go through all of these settings and start to mess with things, although the default settings should be pretty good. So let's just try adding a P of 10 and a D of 120. Guess how I made up those numbers. Okay, app config is written, state is false, switch values 2. There we go. Okay, so now we're on, and you can see it balances really firmly, but if I push it hard, it just goes over the 5 amps of current because we've got very limited power. So now I'll walk you guys through all of the settings and show you what they do. This is going to be, let's go through the right side first while you can see it, and then we'll do the left side, and I'll bring up the wheel so you can see it all happening on the foot view. So there's the PID. I found having an I value of anything is just not helpful at all. So I use a very high D and a slightly high P. The P I found like 5 is a little bit nice and soft, 10 is really stiff. For a unicycle, personally, I like it really stiff. 1 kilohertz for the loop rate is pretty good. You can see your loop time in the corner. I haven't been able to get like the gyro and loop to run much over 2K. I think that's just the speed limit on the VESC processor itself with all the other motor control it's doing. Main axis and cross axis, that defines which axis is which. So if you didn't rotate, like if I didn't do that 90-degree rotation on yaw, I could switch pitch and roll here. But I think it's likely that these settings will be deleted in the future, so you're better off just having it be pitch and roll for your main and cross, and doing all your mixing somewhere else, and then when we remove these, you won't need to worry about it. So now dead zone is an experimental feature, probably also going to be deleted, but if I add like 5 degrees of dead zone, basically it won't balance at all until it's like 5 degrees off from center. So you can kind of see my IMU data. It's like drifting up to 5 degrees, and then the motor power spikes because it wasn't doing anything. And if I show you the wheel in foot view, you can see there's like a huge gap, and then it balances. I thought having a little bit of quiet at the center would help when I was having trouble getting it to be stable, but now that the software is better, it doesn't really seem necessary. So I don't think that's needed. Let me go back to regular view. Okay, current boost makes it so that it's always having a minimum current. So if I set this to like 2 amps, it'll always be doing 2 amps in either direction. So you can see it's spiking much harder. This also seemed useful when it was like a little bit weak. I don't think it's really useful anymore, so these may go away as well. But if you want to have like a softer P value, but a little bit of current boost, maybe that'll do something. But it probably is just going to waste your battery and overheat your motor, to be honest. Okay, so that is everything on the right hand side. Let's switch to foot view. And also I'm getting cotton mouth, and I've been talking for 30 minutes, holy crap. So I'm going to drink some water, and then I'll be back and show you everything on the other side, which is probably what you came here to know. So 30 minutes, and now we can actually start getting to the useful information. I guess there's a lot to talk about. You see the YouTube audience retention rate for this video. Let's see what that is. Okay, so now I'll be on foot view for the rest of the video. So now let me fix in my IMU. So where's my pitch? Roll. Here we go, yaw. So my roll is off by about 8 degrees because it's not actually mounted totally upwards on this thing. So let me change this. What was it roll? So it was 8 degrees low. I think if we add 8, it should look better. What just happened? Where's roll? Why is it? So confused. Thought we added 8. Maybe we want -8. What is going on? Change this to 0. Oh yeah, I think we want like -16. Let's do that. I don't get this at all. Am I correcting the wrong axis? Maybe I am. Let's change this to 0. Change this to 80. I think because the axes have been changed. No, it's just changed pitch. Wait, I set that to exactly where it was. 80. There we go. Okay. Now, when this thing is upright, they're both close to 0. So, yeah, because my pitch is my roll, because I rotated things, these numbers can get kind of confusing. But there we go. Now, this will be easier for me to show you what's going on with the balance app. So, let's go through these settings in order. So first we've got startup, main, and cross angle tolerance. What does this mean? So if I tip the wheel over, we're going to get a fault. Now the wheel is not moving. Now my main axis, we've got 20 degrees of tolerance. That means if the wheel is within 20 degrees of upright in either direction, it'll start up. So I'm going to slowly get it to center. And then you saw it clicked on and centered itself. That is your angle tolerance, and it's the same thing with your cross axis. I could be centered, but it's not turning on. It's not balancing because I'm not close enough. Once I get within 8 degrees, it should, there we go, it just turned on. Now it's balancing. So those are your main axis and your cross axis angle tolerance. Now if you're doing a skateboard style self-balancing vehicle, your main axis tolerance, you probably want it to be a very small number. 0 won't work, but 1, 2, or 3 degrees, so that when you pitch up and get to almost center, it snaps on. Now if you have a big gap, well, so there's this third one here. Let me explain that. There's this centering speed. So now if I set this centering speed to, let's make it 5, which is going to be 1/6, or there we go, 1/6. I'll make it some, USB is disconnected. It'll be some small variant percentage of what it was before. Tip it over so it cuts off. And so now when I center it, it should center itself really slowly. You can see it's very slowly centering. You're going to want, for the skateboard one, a very quick centering speed, but if you have a huge tolerance and a quick centering speed, it'll snap to center super fast. So I found 30 is a pretty good value. It's probably fine for a skateboard style one as well. And just make it a small tolerance on your main angle. Your cross axis, the 8 degrees is probably fine. I don't think you'll ever be that far off, but you can raise it a bit. So there is that. Now once we're talking about that, let's skip down here to fault on the bottom. Now you got your main axis fault and your cross axis fault. So the main axis fault is going to be if you move the wheel more than a certain amount of degrees this way, it'll shut off. You can see that it kind of shut off there. You can see on the screen the app state goes to fault because it bent too much that way. It's going to do the same thing. We're running now. If I tilt it this way, it'll shut off. I've got it set to 45 degrees on the cross axis, 20 on the main axis. The main axis you really should not be leaning much. On a skateboard one, you probably want it to be maybe just before your nose and tail touch the floor. I guess if you're doing fang drags or something crazy like that, you can adjust it to whatever you want it to be. The beauty of open source, you can have no cutoffs and have your wheel run down the street. So there is what those two cutoffs are, and then if you're using switches, the switches will also enable and disable the wheel. The dual switches work with the well-known dual switching method that I'm not going to cover. So there is that. Now, there is one other cutoff right above it called cutoff duty cycle, and this means if the wheel is above a certain duty cycle, it'll shut off. And now this shut off does not have a turn back on. It's just a permanent shut off, and you basically need to power cycle. If you're in the VESC tool, if you write your app config, that counts as a power cycle. But the purpose of this is so that if the wheel is free spinning for too long, it'll shut off. So now if you lift it up, you can see the wheel ramped up super high. If I put it down too soon, it'll actually make a burnout mark on my floor. Ask me how I know. And it'll melt my flooring, which is horrible. And then I gotta sand it off, and then I have a discolored spot where I sanded it off. Anyway, you can see the app state is now dead. If I rewrite the app config, it'll get fixed, or if I power cycle it, it'll get fixed. Now actually, something that I've discovered, so the wheel, the VESC doesn't control a wheel over 95% duty cycle, but I believe you can actually set it to 95% and it will cut off, which is kind of cool. So you can really have it go all the way to the limits. Yep, it did cut off. We lost our USB connection though. Push this guy back in. Oh yeah, this USB cable was bent, but I'm glad we bent the USB cable rather than the USB port on the VESC. Is this cable just like total, no, the device is busy. What does it mean? What does it mean? I think it'll, if I just keep reconnecting, it'll get me in eventually. There we go. Okay, so I guess 95 will work, but if I turn this up to 96, write the app config, it's balancing. See now, it's just running forever, and it's not going to shut off, and I can't put it down. So be careful with changing this setting in testing. I'm actually going to set mine to 94, just to be a little bit extra safe. There we go. So now, it's dead. It also rebooted for some reason. But okay, so now I rewrite my app config. There we go, we're good. So now the last section of settings is tilt back. So tilt back is this wheel's way of letting you know that you need to stop. It's a safety mechanism. What it will do is angle back to tell you various things. Now, you can disable all of these, but the thing to pay attention to is the wheel can only move at 95% duty cycle. So if you go faster than 95% duty cycle, the wheel can no longer balance you in both directions, right? It can balance you one way, but if it has to, so if you try to slow down, maybe it can correct you, but if you go too fast, you'll just fall off the front because the wheel can't spin any faster to bring you back. So these are pretty important. So I've got it set to 75 for default. That's actually, I'm starting to think that might be a little bit too high. So I'm going to put this at 70, which will give me like 25%. Because if you're going down a hill really quick and then you hit that speed and you're pulling a lot of current or pushing a lot of current or whatever it is, and then you try to brake quickly, it's going to take you time to start braking. And then when you brake, your voltage is going to sag, and then your duty cycle might be higher because your voltage is lower, and a lot of things can go wrong. So you want to set a pretty conservative limit. The tilt back angle and tilt back speed This is what I found is a pretty good one. It's actually a little bit aggressive. If you go too aggressive, it's terrifying. The wheel just goes and like almost kills you. I could probably even go for less than 5 degrees per second, like 4, 3 maybe even, might be okay. But 5 is okay. The angle of 15 degrees is pretty steep on a skateboard. You'd probably want less because your feet are further out. And so there's 3 different kinds of tilt back. There's duty cycle, which means you're going too quick. And then I also added high voltage and low voltage. And these are going to tell you that your battery is going to die. So those are super important. So let's set this to, I'm on 12S, so I'm going to set my high voltage to 51 volts, which is basically just over fully charged. And then my low voltage, I'm going to set it to 43, which is really safe. But I don't mind being too safe for now. And I think that's everything. Yeah, so when you're debugging this running state, it's very useful to pay attention to the switch state, all of that stuff. One other thing that didn't happen, and I would like to call out in case it might happen to you, is I was a bit cocky and I turned my P and D values really high right at the start. It's possible that at the start your motor direction is backwards. So your motor and your gyro balance can be not in the same direction, and so you need to go to general and revert your motor direction. Mine luckily turned out to be right, but thankfully I had also set that limit to 5 amps. Let's crank these up to 60 now, so we've got some good power, and now should be able to ride it. Now I also probably want to turn my IMU Mahoney down to like 1.5. Let's make it like super quiet. There we go. Now it is, I don't know if you can see that, but it was a little bit twitchy before. It's still slightly twitchy, but it's incredibly stable right now, so it's pretty good. And this is basically what I would ride. These are the settings I would use. This is probably exactly where it was before. So yeah, that's it. Start off with also your PIDs being very low. You can experiment with your app state just by tilting your gyro without any PID value and see that when it turns on to running, when it turns to dead, what your switches are, all of those things. Make sure your safeties are in place so it will fault out and on the cross axis and main axis and all of those things without ever having PID values set. I jumped the gun a bit there, and I'm a bad example. And it only didn't kill me because, well, 1, it would have only had 5 amps of power, which is not that much, and 2, my motor direction happened to be correct. Okay, I think that's everything. What is our timer at? 43 minutes. That's a long video. Hopefully that answers questions that people have. If you have any questions, ask somebody else. I'm tired of answering people's questions. If you do have any suggestions on how to make it balance better, or if you want to contribute to the source code, please do. This isn't the best working thing ever. It's a good working thing. I think it's enough of a working thing for a lot of DIY people to be happy, but I don't know that it's 100% the most perfect thing ever yet. It's definitely not, and I want it to be the 100% most perfect thing ever. So please contribute. If you're an expert in the subject of self-balancing vehicles, please help us out. I think we're still trying to sort out the gyro being perfectly stable. Sometimes when it turns, it'll curve up or down a little and get a little bit loopy. I've had better luck if you don't use the compensation and you just manually tune it to be perfect. It'll be great, but then you go and ride for 20 minutes and your gyro shifts a little bit by 0.5 degree per second on one axis, and then it's not very good. So for now, the compensation is a pretty good way of doing it. So yeah, that's all I've got. Let's actually see where my gyro is. So my non-compensated, or my manually compensated axis was Y. Oh, I didn't actually manually do anything to it, and it's pretty close to 0. So yeah, and you can see that axis is twitching a lot because that's what my wheel is currently balancing on. Okay, I think that's all I have to say. Hope you enjoy the software. Hope it works for you, and hopefully people will contribute, and hopefully this will be better and better over time. But for now, it's definitely rideable, and it's pretty cool. So I'm stoked to have it. And these settings will probably be different, in the future. But hopefully this video will still be helpful, even if the settings don't match what you saw. Alright, and stop recording without an awkward gap.